Let's look at a function f of x, which is x squared plus 1, for example, and see what happens when we do f of x plus some constant number, let's say f of x plus 2. Now we would think that when we do f of x plus 2, the graph would of this function would shift to the right, but that's not the case. The graph actually shifts to the left. Let's try and intuitively understand how this happens. This is the graph of x squared plus 1. It's a quadratic function. So the graph looks like U shape shown here. Now what does it mean when I change f of x to f of x plus 2? For the same value of x that I put in here, I can get that value of x for a lesser value of x here, which means if I have in place of x, if I put 5 here, the same total of 5 can be achieved here by substituting x with 3. So for a value of 3, I get this value of y here for the function which I would get here in f of x plus 2. So let's say x value is 6. Here for x plus 2 to be 6, I just need 4 for x. If f of this x is 7, then to get x plus 2 to 7, I just need to say 5 plus 2. So you see that x is 6 here, but 4 here, 7 here, 5 here. So for lesser values of x, I can get the same effect of f of x. So for lesser values of x in x plus 2, I can get the same effect of f of x. Let's see how this works in the graph. Suppose this is the value of y I'm looking at this point. I can get this value of y for a lesser value of x. That means I would get it somewhere here, which is equivalent to a shift of 2 coordinates. I would get it here. Same way, if I look at this point, this value of y, I can get for a lesser value of x. I will get it here. So this point would shift here. You see that the point is shifted to the left, shifted to the left. So similarly, the entire graph would shift to the left and look somewhat like that. So you see that when we do f of x plus 2, the graph actually shifts to the left and not right. Same way, intuitively, if we work out for f of x minus 2, the graph would not shift to the left. The entire graph here would shift to the